Hey, let's start this thing off with a little bit of conflict. I'm kidding. I'm not really that kind of guy, but anybody post in the chat if you're looking forward to some playoff games today in football. That's American football. If we have anybody from foreign lands, anybody gonna watch anything today, or just me? I'm hoping to see my Niners beat the Lions. That's all right, Auntie. Not everybody's into sports. I understand. Yeah, Zach, that's what I'm talking about. Go Niners. All right, good. So that's excellent, Alexandra. Going to church is wonderful. Going to say, wow, Bhutan. That's fantastic. Nice to see you. Okay, good. So let's go ahead and get started. Some people will be trickling in as we get going. Okay. So let me move all my Zoom controls around. I have about 5 million of them, which is great. So this is me. I'm Eric Gross. I'm your instructor today. I am a senior software developer with decades of experience in the industry. I've been a nerd for my whole life. I am a veteran of the Navy. I was a nuclear reactor operator and electronics technician in the Navy a long time ago. Leave me alone. I'm old. I was at the grocery store today and they had to card me. I'm like, they didn't just like ask to look at it. They asked me to state out loud my date of birth. I'm like, really? You gotta make me say it out loud? Wonderful. Anyway, I am also the co-founder of the Tech Academy. We're putting on this class, right? More about that later on, but I'm very glad to be here today. I love teaching these things. I just love giving people an opportunity to find out a couple important things about technology and about coding in particular. One is to just learn some of the fundamentals of it. What are the basic principles involved so they can think with it a little more easily? And probably, of even greater importance, to find out whether or not they actually enjoy doing it. Now, the fact is that software programmers, coders, engineers, whatever they're called, we don't spend all of our work time every day coding. In fact, on average, it's probably 25 or 30% of our time is spent actually writing code. But that activity of writing code and all of the other things you do to make that coding work effective, we like people to just understand a bit of what that world is like so they can find out whether it's for them or not and continue their exploration of the industry. And so that's part of why we do these classes. So here's some basic class rules. We do have an assistant in the class, Regina, and you'll see her listed in chat. And that's part of her primary role is to monitor the chat and answer questions. I'm also just going to ask you to be nice because if you're not a nice person, she'll boot you from the class, but that's happens very, very rarely. I do want to stress that even though these are introductory coding classes, they're going to be challenging. You are in fact learning a new thing. I mean, there may be aspects of what we go over that you already kind of knew. There's almost always new things for you to learn, and that's always a challenge. But again, this is your opportunity to find out whether or not this particular activity or industry appeals to you. And your reaction to what that challenge is will tell you a lot about whether it's right for you. We're just interested in finding people that they love this and want more of it. Now, on that, when we're writing code, because you're going to be writing code today, it's important to go I won't say go slow, but to pay attention to the exact things I type on the screen. I'll attempt to go relatively slowly, but one thing you should know about computer programs when you're the one creating them is you're feeding a set of instructions into the computer to make it do work. And those instructions have to be typed or formatted according to an exact predetermined pattern. And if you get one thing wrong about that, it just won't work because computers can't think. They can't figure out what you quote unquote meant for them to do. They will only do what you tell them to do. And it's going to be precise. Now, nothing we're going to cover today is going to be super complex, but just pay attention to that. Write your code exactly as I write it on the screen. That usually takes care of most errors people run into when they're trying to follow along with the work. Another thing that I want to point out is that if you're attending on a mobile device, it's going to be real hard to do the work. You can listen, and I encourage you to do so if you're on a mobile device. You'll still learn a lot, okay? And you can watch the whole event on a desktop or laptop later on because we'll put these up on our YouTube channel. Another super important thing, please have a distraction-free environment. Again, this can be challenging, right? And I want you to have the best possible chance of getting the most out of this. So screaming kids, barking beagles, trying to do this while you're driving. I'm joking, I hope. Just don't do any of that. Just keep yourself in a nice distraction-free environment. And here's another important part. Again, I'm going to try to go to relatively, moderate pace through this, but there's always a chance you might get left behind and not be able to keep up with the typing of the code that I'm doing. It's totally okay if that happens. If you fall behind, just listen and learn. Yes, it does add a lot to type it in, but if you're paying close attention, the same lessons should come home to you and give you a sense of, what coding is all about. I already mentioned YouTube and these videos. It usually within 24, 48 hours, these videos go up on YouTube on our free channel. We'll provide links to all that at the end. And we're going to be building a text-based adventure today. You will have the full code of the whole game at the end of we'll give it all to you in this class, and you'll be able to play it and be able to tweak it and have fun with it and reinforce both some of the things you've learned and honestly, probably learn some new things. So finally, I mentioned links to the YouTube channel. We're going to provide a bunch of links at the end to future events, that free learning content, other resources. So stick around to the end. Now, we do have a chat. Many of you have been using it, which I appreciate. There is a separate thing in there called a Q&A. That's part of the type of account we have with Zoom. Ignore that. Don't use the Q&A. We don't monitor it. Just use the chat, and Regina and I will be watching that. Let's go and test that chat out really quickly. I'm seeing a little bit of traffic in there. Everybody do me a favor and pop in right now and just type in where you are joining us from to watch this class. Maryland, Richfield, Washington, Seattle, Vancouver, Washington, Bhutan. Oh, more Canada. Stu McLeod's in Portland, Oregon, Boulder, Colorado, Houston, Texas. That's excellent. Louisiana. That's right. That's where I am. All right. Puget Sound area of Washington. I was stationed there for 2 years in the Navy. I was stationed in Bremerton. What a beautiful place. One of the most beautiful places in the world is the Puget Sound area. And Oswego, New York. I've always wondered, Crystal, we have in Portland, where I lived for 30 years, a smaller town right outside of Portland called Lake Oswego. And I don't know whether I'm pronouncing it the same way that Oswego, New York is pronounced. So is it Oswego? We always say Lake Oswego. And we got people from Long Island, Fall Creek, Oregon. Lived in Oregon 30 years. I have no idea where Fall Creek is. All right, good. So we have people from all over the country. And in fact, people joining us from outside of America, which is fantastic. I'm glad to see you all. Okay, good. So here's the basic agenda. We're going to have a short explanation of the Tech Academy, really brief. Then we're going to write code. You're going to actually get your hands dirty writing code. And we're going to do it in such a way that we're going to teach you the fundamentals of all computer programs, not just computer programs written in Python, which is the language we're studying today. When we're done with all that writing code, which is going to occupy the bulk of the class, we'll have a brief Q&A session. We try to have time for all of the questions, but sometimes we run out of that. You'll have an opportunity to send your questions in, though. Then we're going to go over some information about our boot camps. And I do encourage you to stick around all the way to the end because we have a free gift that we give out, and I want you to get that. It's actually pretty valuable. The total class takes about 1.5 hours. We might get through in less than that, but if you look at your schedule on this wonderful, hopefully not too cold Sunday, we're looking at about 1.5 hours. All right. So brief explanation of Tech Academy. What are we? Well, we're a coding boot camp. We actually offer 12 different boot camps, but let's just look at the concept. A coding boot camp is an intensive educational program in an area of technology designed to get you employment ready. They started out around 11 years ago. We've been around for over 10 years. Actually, it'll be 10 years in 2 days. Yeah, right? And we've been offering budget-friendly, thorough, flexible, trusted coding boot camps for, like I say, over a decade. We have a bunch of certifications, a lot of them, and they're all beginner-friendly. In other words, you don't have to have prior technology knowledge. They're self-paced, which is wonderful, and they cover a huge variety of disciplines. We'll show you that. We teach in-demand skills. We teach what the industry needs right now, not something that. Well, I'm going to let you in on a little secret. One of the challenges of running a big academic institution, like say a college, a university, is that making changes to the curriculum is quite difficult. Difficult mainly because it takes a long time for the approval process with all the different people that want to have a say in changing curriculum. It can take 18 to 48 months to make any kind of significant change to a curriculum in a college setting, right? Because of that, when you're learning technology in that environment, it's guaranteed that what you're going to learn is at a minimum 3 to 4 years old. Usually, in terms of the principal elements of it, you're learning 15 to 20-year-old technology. We don't teach that. We teach what the industry uses now. Okay. Now, I don't want to knock on, colleges. You learn a lot of stuff in college. It's just not time for in a boot camp. It's a whole separate subject. Finally, our programs are really affordable. They start at $5,300. We're priced well under the national average. And I'm telling you all this because I just want you to know about who we are, what our mission is. This is the mission statement of the Tech Academy: to graduate entry-level technology professionals that excel in the basics of their field and thereafter have successful careers in the tech industry, and whose actions raise industry standards and surpass client expectations. That's what we're all about. Our product is you working in technology. All right, so let's look at some basic definitions that'll help you to think with what we're going to learn today. The first one is just, what is a program? This is a programming class. Well, you can see that a program is a set of written instructions. I kind of referred to this earlier, that you enter into your computer. Now, these aren't the instructions you enter into when you are yourself using a program. Like, it's not instructions you might enter into Microsoft, Excel, or into a game you're playing. No, these are the instructions that cause one of those programs to come into being. And all the instructions you enter are designed and oriented around specific tasks. You make the computer do the work for you. How do you enter those instructions in? What do they look like? Well, they're written in a programming language. And a programming language is just like most languages, it's an organized system of words, phrases, and symbols. And it's there to allow you to communicate with the computer, specifically to give it instructions that the computer itself can understand and process. And since computers can't think, the instructions have to be very precisely formatted, because you're feeding them into a machine that can only understand what it's been told to understand ahead of time. Programming languages, this is what we use to create these computer programs. All right, next definition is coding. Well, this is a verb. Coding is just the action of doing what we just talked about. When you're entering those instructions in, you are in fact coding. You are entering in instructions that will end up making the computer do something. Now, as a noun, code is those instructions that you enter. If you're writing a program, a set of written instructions, those instructions are called code. You could say, in the following 5 lines of code, and that means there'll be one line of instructions after the other. Code is a noun in that case. All right, now, this is a class where we use a language called Python. Python is amazing. First of all, it's an extremely popular computer programming language, and it's been around now for 35 years. So this Dutch computer programmer that created it was quite young when he did so, and he pulled off something really, really cool. It is both easy to learn and understand, but also very, very powerful. You'll see when we start to actually write some of the code that the instructions you're going to enter, they resemble common English words. So it makes it relatively easy to figure out what the code is trying to do, right? And it makes it easy to work with. And you can use Python to make almost any sort of program, whether it's an app that will go on one of the mobile devices, whether it's a website that you're building or a game, all sorts of things can be built in Python. We're going to just scratch the surface a little bit today with what Python is capable of, but I assure you it's a lot and it's worth learning. All right. Now, we're about to code, but we're going to go over a concept here before we code, because if you will grasp this concept, every computer language you attempt to learn will enter your mind much more easily. You'll be able to work with the language that much more easily. You'll be able to do your job as a technologist much more easily if you'll know these 5 elements I'm going to go over. We're covering, and you can see it on the screen, what are called the 5 elements of a computer program. And here's the thing. These are going to sound really, really simple. And that's because they are. And in fact, one of the things to know about technology is that even though it can appear to be really complex at first glance, the concepts underneath all of it are actually very, very simple. And these concepts I'm going to lay out here, this is what plays out in every computer program ever made. A simple, tiny list of to-dos, a program for making, keeping track of tasks, or a super complex program like Microsoft Excel. Every single program makes use of these 5 elements. And again, you're going to learn these 5 elements by doing in a few moments, but I want to cover what the concepts are. So these 5 elements that any computer program has, first one is it has an entrance point. This is, if you're entering instructions into the computer, if you're, in other words, creating a program, you got to start somewhere. You have to have a first instruction. Every computer program has one. And it's valuable for a lot of reasons. We go into a lot of detail on this on the boot camp, but the primary one is if you want to follow through a program and see what it's going to do, start as close to the beginning of the instructions as possible. And if you can find the first instruction, it makes understanding the rest of what that computer program does a lot easier. So the second type, I left this on the screen, I apologize. The second type or element of any computer program is what we call control or branching statements. Now, these are instructions you enter in a computer. They will tell it how to choose between one of 2 or more available options. This is something we do in real, outside of using computers all the time. When we're doing our work, we have to make decisions. In just regular personal lives, we have to make decisions. So if you're going to make a program that will help us get work done, you have to have some sort of a construct or mechanism inside the computer program that will allow the program to make decisions based on whatever the user choices are. Now, the reason they're called control statements it's pretty clear. I've said that you're going to control the direction of what the computer does. The different possibilities of what to do are called branches. Think of a tree limb, or think of a tree, and you're moving up the tree, and at various points you have the choice to go off on a branch or off on a different branch. This is what the origin of that word is. So that's the second key element of any computer program. The third one are variables. Remember, we're inside a computer program. We're inside a set of instructions that's making the computer do work. And the computer is working with data. Much of the data the computer will be working with while your programs are running could change from moment to moment. Think of a simple example of a computer program that helps you administer a retail business where you sell bicycles. And you have 5 different models of bicycles. And when they come off of, they come in from overseas from the manufacturer and you register them in your warehouse, your inventory figures change. In the morning, you might have 100 bicycles that are colored red of a certain model. And by the end of the day, you might have 130 because a new shipment arrived. Your computer program needs to be able to keep track of data that can change while the computer program is running. If you had a program that could not adapt to changing real-world conditions, it would be very, very unuseful. I don't know if that's a word. It wouldn't be very useful. So a variable is a way to keep track of data that changes when your computer program runs. All right, fourth element of any computer program, and these are amazing. They're called subprograms. They were one of the first huge developments in software back in the 50s and 60s. The concept is really simple. If there's a set of instructions, in other words, a computer program is a set of instructions. If your program has a little set of instructions that you end up using over and over and over again as your program runs, It's very valuable to take that small set of things that you could use over and over again, give them a name, and set them off to the side as what's called a subprogram. And then whenever your main program needs those things to occur, you just ask for that subprogram to run, and it will. And it's really beneficial for a lot of reasons. But that's what a subprogram is. And any decent computer program makes use of these. And you're going to build them today. Finally, the last element of any computer program that it has to have is an exit point. We need a way to tell the computer, hey, that program that you're running, it's over. It's done. Fini. There's nothing left for you to do. Why? Why do we care about that? Because the computer that's running your computer program is doing several things under the hood to help your computer program run. We're not going to get into all the details under the hood. Again, this is something we teach in detail in the boot camps. But suffice it to say that while any program is running, again, let's say you're using Microsoft Word on your computer, right? Your computer itself is managing a lot of things behind the scenes that help the Microsoft Word program work properly. The moment you close Microsoft Word, your computer needs to know so it can stop doing all that extra work just for that one program. So every computer program needs an exit point. So here you have, by the way, arguably the more important thing we could teach between coding and this slide. In other words, this slide represents some of the most valuable data you will ever encounter if you're seeking to figure out how to, whether or not computer programming is for you and how it works. These 5 things will be present in every computer program. And if you have to study a computer program that you didn't write, this is what you use as a mental framework to figure out what's going on. And therefore, maintain that computer program or make it better over time. All right, so enough of me yapping. I want to write some code. You all want to write some code? Now, we use what's called a code editor here. This link is going into the chat. I want you to go to that link, open it up, right? This is a place where you can write your computer instructions, your code, and then run them to see what they do. Now, I have my code editor. I will prep everything here so you can see it. All right. All right, let me share my screen again. Okay. So this is a neat little website that's out there for people to use when we write these classes, or when we do these classes. And it's pretty simply divided. On the left is where you're going to write code. You can see I can write and type in here. On the right is the output. Now, you've already probably got some code written in there. You can delete all that. We're going to overwrite all of it. Now, what I want you to do first here is I want you to set it up so that you can see my screen on the left and your code editor on the right. Let me show you what that's going to look like. So this is what opens up. I want the instructor's presentation, my Zoom, right, on the left, and that window on the right. Sometimes in order to make Zoom behave and have it occupy just the left-hand side, you have to use this little restore button. Sometimes you have to drag it over the left and have it occupy that, half of the screen. I'm going to give you a minute to set it up that way. And this is what it will look like when you do side by side. I'm going to let this animation play. You can click on that resize icon, and it'll let you move the windows. Now, Many of you already know how to do this. And once in a while, we find people that haven't done this kind of thing before. And by the way, if you have 2 monitors, you got no problems at all. Just use the 2 monitors. All right, so let's move into the coding. This is going to be a blast. Now, we just spent a bunch of time with you having to listen to me yammer on about these 5 elements of a computer program. This is, however, the best model we have found to learn a new language. So we're going to actually go through each of those 5 things: an entrance point, control and branching statements, variables, subprograms, and an exit point. We're going to go through each of those in Python. So you'll learn the basics of Python and reinforce how those 5 things work. Let's start with the entrance point. Now, one of the things that's built into Python, as in many languages has, is an ability to print things to the screen. And it's pretty simple. Just type print, P-R-I-N-T. This is a built-in functionality that Python just gives you automatically. You can put things on the screen. Now, the way it works is right after the word print, the Python language expects a set of open and closed parentheses, and inside the parentheses is what you want to print on the screen. So it looks like this. Do an open parentheses. The code editor will automatically create the closed parentheses for you. It's called autocomplete. It just makes your life a little bit easier. Not all code editors do that, but we like this one because it does. Now, we want to print something to the screen, and it needs to be what are called alphanumeric characters. That's going to sound all fancy. It just means letters and numbers. Alpha for letters, numeric for numbers. Alphanumeric. So all of what you want to print should go inside double quotes. Now, the double quote is just to the left of the enter key. It's not 2 single quotes typed one after the other. It's above the single quote on the key. So you give a double quote, and then you put what you want to, whatever you want to do. So let's put in here, what is your name, ? Type that in between the double quotes. And when you're ready, you can go up here and actually run the program. It's a program with 1 instruction. What is your name? Hey, that worked. Now, I know it's really simple, but it just gets you comfortable with how the language works. And here's a very basic principle. If there's a command in the language that tells the computer to do something pre-built, to perform a pre-built action, in almost all languages, and especially in Python, the name of the thing you want to do, in this case print, is immediately followed by parentheses. And inside the parentheses, you put things that are needed to do the work you asked for. We asked for something to be printed to the screen, so we most definitely thing that should be printed to the screen. But the basic principle here is that print is actually an example kind of a little subprogram, a mini program, a mini instruction built into the language. And as you're going to see later on, when you ask for something pre-built to be executed, to be performed, you very often have to give it data it needs to do the work. And that's all this is. All right, now we're studying this whole concept of the entry point, the first instruction. Now, let's do a second instruction. We will do a print. What game do you want to play? follow the same context, the same syntax. I will leave this right here for you all to get caught up. And then run it. And again, you should see the output off to the right. And we've executed 2 instructions. Great. All right. Excellent. Fine. Now, to show you how this first instruction thing works, we're going to jump ahead a little bit and then come back, and I'll show you what we're going to do. We're going to use, the next thing we're going to talk about is these thing called variables. I mentioned variables, which are ways the program can keep track of data that might change while the program is running. One thing that might change is the name of the player. And this is common in lots of scenarios. It's common right here in Zoom. When you log into a Zoom meeting, you can change the name that's displayed. I had to do that this morning before we started. I'm using a company account at the Tech Academy. When I logged in, it had the company name in there, so I just changed it to say Eric Gross. This is a very common thing. Now, again, because we need a way to keep track of data that might change, almost every single computer language has a thing called variables. In Python, all you need to do is type in the name that you want the variable to have, and then what data is inside that variable. It looks like this. We're going to have a way to keep track of the name of the player. So the variable is going to be called player. Type P-L-A-Y-E-R, space. Now, so we've made the variable. There's a variable called player. That's all it takes in Python. Just put the name in there. And then do an equals and a space. Now we're going to put the data inside that variable. What's the value that that variable holds? We're going to put double quotes, and then you put your name. I, of course, am going to put my name, but you put your name, whatever it is. That's all there is to creating a variable. But we want to use them for things. It's quite common to display the name of a player or a user on the screen. So let's do our print command again, P-R-I-N-T. Remember that this is an instruction that needs data, so you put it inside parentheses. So put your open close parentheses. Now this part's important. The first time we used this print command, we had to put what we were going to type out inside of these double quotes. We did it up here with what is your name. We did it right here with what game do you want to play. But what we're doing instead is we wanted to print Eric, but we have a variable that has the value Eric in it. All you have to do is give that variable called player to the print command by putting the variable inside the parentheses. And it looks like that. Type P-L-A-Y-E-R. You don't need quotes. You're taking the variable called player and you're giving it to this instruction called print. Print will look at what's the data inside this variable. In this case, it's Eric, or it's going to be your name. And it'll print the data. It won't print the word player. It'll print the data inside the variable called player. Go ahead and run this. And you should see what I have. The first instruction, the second, and now this third thing where we've been able to print the value of player. And again, you should show your name or whatever you put in these double quotes. Now, I mentioned this whole idea of a first instruction. I want you to see something really cool. Let's say the first thing we want to do is to print the name of the player. I want you all to copy this bottom line, and then you can cut it. You can usually do that by right-clicking on it and doing cut. You can do it by using Control X or Command X, but cut it. Now it's on your keyboard. It's gone. We're going to move it all the way to the top. So go to the very top, hit Enter, And then I want you to paste it. You can do that again by right-clicking and do paste. But this is what I want. I'll give everybody a moment to get caught up. Now I want everybody to run this. And you'll get some kind of really weird error message. Don't try to analyze what all this is. You learn about how to think with all this stuff and understand what's going on our boot camps. The most important thing is the bottom message that says name player is not defined. And let's just look here for a moment and think. Computers operate on the basic principle that you give them one instruction to do. They do that instruction, and only when it's done should they move on to the next instruction, and so on and so forth, one after the other. So we talked about the first instruction, like the fact that of these 5 basic elements, the first one is you have to have an entrance point. Right now, the way this program, this is a very simple program. We have 7 lines of code. The way this program is written, the very first instruction that you're telling the computer to do is to print player. Now, you and I, this is really important, you and I can look at this page and look down here and go, okay, so we have a variable called player. We've set the value of it to whatever your name is, in my case, Eric. If I can see that, why is the computer trying to do this command and having a problem? Can't it go down and see that I, in fact, created a variable called player? And it can't. Now, I know, again, for those of you who mess around with coding at all, this might seem super simple. But when you start building more complex computer programs, I can't tell you how many times during your learning journey you'll do something like this, and it'll be real confusing. The point is that the computer doesn't know anything about what happens later in the program. It only knows the things that have come before and what you're asking it to do right now. So the first instruction we tried to execute is this. And because we tried to have it use a thing that didn't even exist yet, this variable called player doesn't even exist. Python goes, sorry, what? You've got this thing called player. Let's go over here. You have this thing called player you want me to use. You didn't even define what it was. So let's go ahead and take it and move it back down to the bottom where it belongs. And then let's give us our lines back. All right, good. Now, so far we've covered an entrance point. There's a first instruction to be executed. We've covered variables, right? And why not have fun here? And you change this and run it. Change it to a different name. And in fact, let's do this. Go to the very end, all the way down at the bottom here, and let's give player, P-L-A-Y-E-R, a different value. Banana. I know, it's a silly name. Now, when we run this, before we run it, you tell me what it's going to output. I don't need to say it in chat. Just think ahead what your answer is. Run it, and it still prints David. But we changed the value of player to banana. Yeah. But at the time we gave the instruction to print the value of the variable player, the value of the variable player was David. Now, if we go to the very bottom again and do a print, print it again, print player, make sure you type everything right. Now you'll get banana. Again, I know these are super simple. I just want you to start getting comfortable with creating instructions, with making sure they're formatted properly, and with these central concepts of an entrance point and variables. Now, though, we're going to move on to these control and branching instructions. And these are super important and super valuable when writing programs. Remember, what you're going to look at today, you're going to see the full code for it here in a little while, is a text-based adventure. A computer program, that you make choices and you choose your own adventure, right? Well, clearly, there's decisions to be made. You're asking the player to enter in their decision. So we're going to build some computer code that can handle them making a choice. So the first thing we need to do is we need a variable that represents what did the player choose. Now, I'm going to take all this and I'm going to show you something kind of cool. So give me just a second. You all don't need to do this at all. Do not follow along with what I'm doing yet. I want to show you the program. Now, again, there's a lot going on here. We're going to analyze all of it later on. This is the full program for a text adventure. You're going to look at details on this later, but I'm just going to run it. Let's look what happens here. Go ahead and read through this for a second. So here we are, and we've provided the reader with some choices. I'm going to end the game really quickly. I'm going to choose 2 for, 1 for walk off the cliff. Oops, you died. Let's try again. Okay, good. So this is how the game works. And obviously, based on your choices, different things will happen. Let's go back, though, to what we're doing. We need a way to represent what number did the player choose. So we need a variable called choice, C-H-O-I-C-E. That's our variable. And we're going to say that they chose option 1. That's the value of what they chose. They chose option 1, like I did when I decided to jump off the cliff or walk off the cliff. So I've made a variable called choice equals 1. Fine. Now let's see how we use these control and branching statements to choose one of 2 or more possible paths or branches. You do that in Python and nearly every computer programming language with a command built into the language called if. Type if, I-F. The way if works in Python is that it needs data in order to do its job. Just like print needed data to do its job. Print needed, well, what's the alphanumeric data you want me to print? Whether you typed it out or whether that data is in a variable, the command print needs some information. Well, the if command needs information too, and it needs a thing that can be checked for whether or not it's true. Think about this. You're walking down a path and you come to a fork in the road. And to the right, it says you can go to Boston. And to the left, it says you can go to Philadelphia. And the signs include the distance to each. You've got a decision to make. And let's say the decision is based on how much food you have in your backpack. You would write that. Don't write this out. I'm just trying to illustrate what I'm talking about here with this made-up hypothetical of you're at a fork in the road. You might go to Boston. You might go to Philadelphia. Boston is 5 miles away. Philadelphia is 100 miles away. You have a choice to make. Probably that would be based on how much food you have. So you would type out, and again, this is not the way you write. If supplies greater than 7 days. That's not how you write the language. I'm just illustrating a concept. If you had 7 days of supplies, you would probably go to Philadelphia because you have enough time, enough food to get you there. If not, you'd go to the right and go to Boston. Again, I'm trying to illustrate a concept. Computers operate the same way. You're forcing it to make a decision. The if says, hey, computer, make a decision. And the computer says, all right, give me the criteria for whether or not to do a thing. And the criteria is what goes inside these parentheses. There's a lot of complex ways you can write what's inside the parentheses, but they all result in this: being able to look at what's inside the parentheses and tell whether or not it's true. Let's do this simple one. Let's do if choice, that's our variable, C-H-I-C-E, equals 1, what do we do? Now, this part's ultra important. In almost every language, Python included, if you're checking to see whether or not something is equal to something else, whether they match, whether they're the same, identical, whether you're testing whether something is the same, you use a special symbol, which is 2 equal signs, one after the other. Equal, equal. You don't say equal, equal. You say equals. We're saying if the variable choice equals, and in this case, we'll put quote 1. Now we have a criteria. We have a very cut and dry decision. What's the value of the variable called choice? It either is or isn't equal to 1. There's no in between. There's no ambiguity. And that's how these control and branching statements work. All right, so because it comes up in classes often, I want to explain something. This equals is utterly different than these double equals. I know they look very similar, but remember that a computer programming language is a collection of words and symbols. This symbol, the equal sign is a symbol, means a completely different thing than the symbol, which is 2 equal signs, one after the other. The single equals means assign the value that's to the right of me to the variable, which is to the left of me. That's what this symbol means precisely. It says, hey, computer, right before me is a variable. Right after me is some data. Put the data in the variable. That's what this symbol means. Now, this symbol, 2 equal signs, looks remarkably similar in the way we read language. To the computer programming language Python, it means a completely different thing. It means, hey, computer, to the left of me is a piece of data. To the right of me is a piece of data. Check whether or not they are identical to each other. True or false? Are they identical? That's what this symbol means. And I know because they look remarkably similar, and because we're used to using this symbol in math all the time, it can be easy to confuse them. That's one of the things about computers is we have chosen arbitrarily these things that we use all the time in our own written language to mean precise, exact things to the computer. Why am I harping on this so much? Well, 1, it's a question that comes up. But 2, remember when I said at the beginning of this class, to try to pay attention and type exactly what I said, I got a true confession to make. I cannot tell you how many times I've been in a hurry and forgotten the second equals. And then my code is throwing errors all over the place. I can't figure out what's wrong. And I'm scanning through it. And sometimes it takes me a minute to catch, oh, I forgot the second equals. Now, whether that scares you off of coding or makes you go, oh man, all right, I guess it's part of the beast, nature of the beast. That's an important thing to know. 1 tiny character being different can make your computer code not work. But if you master all that, you can write really powerful programs that help people a lot. All right, so back to this control and branching thing. We're going to control which branch of code is going to run. We've already got one choice here. What do we do if the variable called choice is in fact equal to the data 1? Well, the way you write this in Python is at the end of the if statement, after the parentheses, you do a colon, and don't hit enter yet. The things that you want to occur if the criteria are true go on the next lines indented by 2 spaces. If what comes after is not indented, it's not part of what to do if the condition is met. Now we'll write it out. This will be a lot easier to, I'll say that same thing once we have some code on the screen. But when you hit enter, notice that this code editor automatically has indented 2 spaces. It's moved in 2 spaces. That's just a nice convenient thing for you as a programmer. Not all code editors do that, but this one did. So we're about to put in, what do we do if the variable choice is actually equal to 1? Well, let's do a print. We're going to print something to the screen, print. And what we're going to print is, you chose to attack the troll. He defeats you. So in double quotes, double quote, you chose to attack the troll, period. He defeats you. That's not fun. Give you a second to get caught up with your typing. Now, there are other choices. Remember, we have different options. We've got what to do if they say 1, 2, or 3 that we're going to build here, right? But here's another important thing about coding. And honestly, about any technology subject that deals with a complex system where you are able to modify the system. And believe me, a computer program is a complex system. It can have lots of different parts. Here's the basic principle. When you introduce a change to the system, test what that change did before you introduce another change. That will save you countless hours of pain and frustration if you'll grasp that. Now, what does it mean when we're writing programs? It means when you've added a new functionality, some new little feature, even before it's fully built out, just test that it can at least be used. In other words, we already know that all of this code was working. We were able to print a couple things to the screen. We were able to create a variable called player. We were able to print the value of that variable. We were able to change the value of the variable and print that new value. We already know all that stuff works. But now we're going a little bit different. We're using this if thing. When I'm coding, and we teach this way in the program, would prefer to test little bits of my code at a time. So let's test this one. Let's run this and see what happens. Well, we get the first 4 things like we expect. And we do, in fact, get, you chose to attack the troll, he defeats you. If you didn't, and this is really important, if you didn't get that, if you got an error, that is a good thing. Let me explain that. If we had gone on, if we hadn't tested anything, if we hadn't tried to run this, and we just gone on to add in the other options, now if we run it and there's a problem, we have that much more code that we just added that could contain the problem. And this is real critical. Look, I meant what I said at the beginning of this. When we put these classes on, We're trying to give you a little bit of a sense of what the job is actually like when you're actually writing code and when you're designing computer programs. And one of the most important aspects of it is that most of the time when you write something with any degree of complexity, it won't work the first time. It's kind of a weird thing. We were in a weird industry. If we were stonemasons, building brick walls, you can't just build the wall, see how it does, made a mistake, tear it all down and rebuild it. Not very practical. In computer programming, we can do that all day, every day. And that basic principle is so valuable. Test minor changes first before you add in more complexity. It makes your life so much easier. But again, it's a good thing. It means you found the problem right away, you can fix it and then move on. All right, so if you haven't caught up by now, keep on listening. But if you have caught up and you did in fact get the print that you choose, the print that's based on the value of the variable choice, let's move on. What do we do if they said 2? Well, this is important. We have a code editor that's trying to help us. Go to the end of that last line of code, hit enter. Do not start typing right where the cursor is. We want a new option. We want to know what to do if the person entered 2. If we were to start typing if, don't do it, don't type, choice. If we were to start typing right here, this instruction is part of what to do if this condition right here is met. It'll only happen if choice equals 1. Now, that may sound like a real simple thing. Again, super common mistake when you're learning. So what do we do? Well, we want to backspace all the way to the beginning. This is a whole separate thing. In fact, just to make the code readable, I like to hit enter once and give myself a little space because it's very clear what the choice is to be made right here, what decision, what criteria, and what code will run if that criteria is met. We're going to do another one. This is if the choice is equal to 2. So follow the same convention. If remember your open and close parentheses. This is where we put the condition we're going to check. The condition is either true or false. So if choice, C-H-O-I-C-E, remember, is equal to, that's 2 equals, and then double quote the number 2. When you hit the colon, now everything below that is indented will be part of what to do if that condition is met. So you hit enter, and we're going to do another print, and we'll say you chose to befriend the troll. You chose to befriend the troll, period. He betrays you. He's a troll. I'm sorry. What are you going to do? He's not going to be some big friendly troll. All right. Now, if we run our program right now, it's still going to say you chose to attack the troll. He defeats you because we set choice equal to 1 and we never changed it. Let's just change it to 2. Change it to 2 and run it. Hey, it says you chose to befriend the troll. He betrays you. Okay. All right. Well, that works. Good. Let's do one final one and then we'll move on. Now, remember, when you hit enter, you're indented. You want to backspace. We're going to do a final if. If, in parentheses, what's the condition we're going to check? If choice is equal to 3. Should we start to see the pattern here? Do a colon, and when we hit enter, it automatically indents. And now we're going to print that we tried to trick them. Print Remember the parentheses and the double quote. You chose to trick the troll. You escape him. Remember, trolls aren't very bright. All right. Now we have 3 choices. Go ahead and run this. It should not choose the third one. Change our choice to 3 and run it. And it should print the third one. You chose to trick the troll. You escape him. Okay. All right. This is working. So what I know this is a real simple thing here. It's the principles that are most important. We have 3 branches of code. How can you tell something's a branch? It's a branch of code if there's a possibility it will never be run. Let's look at this. This line of code might never be run. I know it's unlikely, but if every if every player of our game that ever used it, if none of them ever entered 1, that line of code would never be run. That's a branch. That's a branch. It's a path of code or a branch of code that is only run if certain conditions are met. And this gives you tremendous control and power over the functionality of your computer programs. Again, we put a very simple thing in here. One of these branches is just going to print something silly on the screen. You chose to befriend the troll, he betrays you, or whatever. But they can be a lot more complex. You can have a whole separate chunk of code that happens only for, say, VIP members of your website, where every single product that's offered automatically has a discount applied to it. You see the value in stuff like this. Someone's entering in a coupon code on a website. You'd have a section of your code that would verify whether or not the coupon was valid. And if it was valid, reduce the price of the product in their shopping cart. If it wasn't, give them a message that says, I'm sorry, that's an invalid code. We encounter this stuff all day long. And as the programmer, you're in charge of determining, 1, what are the possible things that can happen, to be done, and 2, making the code reflect that. This is powerful. All right, now, last thing. We talked about subprograms. What if we put this person in the player in the same position to figure out what to do with trolls over and over again? Let's just say they're traveling through a land where, like as not, often as not, they're going to encounter a troll. We don't want to have to type in these lines of code every single time our player encounters a troll. For a lot of reasons, not the least of which it wastes a lot of our time. But also, there's just more possibility of error when you're writing it. And finally, what if we wanted to change what happens based on their choice? Now we have to track down every place that we put in all these possibilities and change every single one of them. So this set of control and branching instructions is perfect for a subprogram. Let's say we are going to have a subprogram that we can use every time someone encounters a troll. Let's make that subprogram. We're going to call it, we're going to give it a name. But when you're making a subprogram in Python, they're called functions. And we use the command def for define. We're going to define a function. Let's give the name of it. We're going to call it troll. This is what happens when we encounter a troll. Now, this part is super important. When you're making a function or any subprogram in any language, for that matter, when you're making a function in Python, you have to decide whether or not that function needs information to do its job. Now, this function we're building clearly needs information to do its job. It needs, what did the player choose? So when you're designing this subprogram, again, we call them functions in Python. When we're designing this subprogram, we need to put parentheses right after the name of the function we're creating and list out what are we going to give to it. You're going to give it a variable because it can change every single time we use the function. We give it a variable. We're going to call this variable player underscore. This is underscore. It's usually in the top row of keys, just above the dash. So shift dash, player underscore choice. That's going to be given to this function every single time we ask the function to run. So the way you start, where you finish off this defining line is you put a colon. It's not a semicolon, it's a colon. Same thing as the if statement before. When we hit enter, it'll automatically indent for us, and everything that's indented is what happens when we call on this function to be run. This function called troll, whenever we call for it to run, we're about to lay out what's going to happen. So it's going to be the same options. So let's make it easy in the interest of time. Go ahead and copy all three of these ifs. I'm going to leave it highlighted so you can see what I'm copying. Control C for copy. Go down here where we're indented. Now, this paste, sometimes it doesn't work very friendly. So hit paste. Yeah, let me show you what happened here. Everybody look closely so I can show you how to fix this very easily. You know what? I don't want to do this. This is silly. Reverse that and go back to where we are now with nothing below the defined troll. I'm going to give you, we got a little time here. We're going to get your hands dirty again. We're going to type them all out again. So put your focus on what we're building. We're building a subprogram. Again, in Python, we're calling it a function. And this is something that's given a name that we can call upon over and over again as needed. And inside it is a series of instructions in our code that will happen whenever we want them to. What do we want to have happen? Well, we want it to figure out what the player chose and print something based on it. So let's do an if, and we're going to check the value of something. We're going to check a condition. What this subprogram or function called troll was given is a variable called player choice. That's what it was given. And you'll see us use it in a moment, but it's going to receive a 1 or a 2 or a 3. It's going to receive a variable that has the value 1 or 2 or 3. So we want, when we're going to make decisions inside this function, we have to use that variable to make them. So here we're going to say player choice, P-L-A-Y-E-R, it's the underscore choice. Make sure you type it perfectly. And then a space, and we're checking equality. We have to make a decision. We're putting a condition in here. So double equals, and then the double quotes in 1, just like we did before, but it's a different variable we're checking. If you put the colon at the end of the if, now let's type in what to do. We're going to print same thing. You chose to attack the troll. He defeats you. All right. Hit enter. Now we've got our first branch. Let's do the second one. Remember that you have to backspace 1. You need to start typing not inside the level of this if statement, but at the same level as the if statement. This print is inside the above if. We don't want to be there anymore. We want another if. So type an if. Let's check the variable player choice, PLAYER underscore choice. We're going to check equality. So it's a space and then 2 equals to check equality. And is it equal to, quote, 2? Go to the end and hit colon. So now we've got a second branch. What's going to happen on that branch? You hit enter and notice it automatically indents for us. We're going to print, you chose to befriend the troll. He betrays you. Go to the end and hit enter. Now we want a third one, but again, you don't want to type the if here because you're indented and you're inside that second if. Hit backspace and you're no longer inside the second if. You mean if, and this should be pretty clear at this point. Player choice, double space, double equals 3. A colon, and it'll indent for you. And then we print, you chose to trick the troll. You escape him. All right, now. Watch this. I want us all to delete this middle section of ifs. Get rid of them. Get rid of the variable called choice. So we are going to use a variable called player choice. Let's make that variable player underscore choice. Let's just all think we're going to be giant warriors and we're going to make it equal to 1. That's the first thing we do. So everybody set that up. All right, I'm going to look at chat here for a second. I want to have a little bit of fun here. Listen very carefully to the question. And I'm going to ask this in a very precise manner because it speaks to the nature of how computer programs work and how you have to think as an engineer, as a developer. So the question is very precise. Put into the chat what you think the final thing is that will be printed when I run this code. Put into the chat what you believe to be the final thing that will be printed when I run this code. HE says banana. L says you chose to troll. Stu, I like your answer, but some things are going to get printed. You chose to attack the troll. He defeats you. Okay, good. Yeah, we have some people that are totally know where I'm going with this. So let's run it and I'll explain. Banana is, in fact, the final thing that gets printed. Some of you recognize immediately why. Some of you weren't sure. And by the way, this is very common to not be sure about how this works when you're first starting. So this part is super critical. And we're hitting the end of the coding. I'm going to show you the full program and move on to some other really cool things. But this could be one of the more important things I'm going to teach. I said earlier that these 5 basic elements of programs exist, right? And one of them is this thing called a subprogram. Well, here's the critical thing to understand about a subprogram. And again, they're called by many names. Different programs call, or different languages call them subprograms, subroutines, functions, methods. They all amount to the same thing, and it is this. A subprogram is a set of instructions that will be executed only when requested by another part of the program. It's a mini program that only runs when another part of the program asks for it to be run. The word that we use is that the other part of the program calls the subprogram. That's the terminology. So what we have here on my line 15 in this function called troll, this and all of the code inside of it, this is only a description of what will happen when we ask it to happen. When some other part of our program asks this mini program to run. Because make no doubt about it, lines 16 through 21 are a mini program. Is this not a program? This is 3 instructions that can be executed. It's a mini program. But the big point is this function that we've defined is a description of potential behavior. It only happens when we ask it to. In Python, the way to ask it is really simple. Type out the name of the function, TROLL. Put parentheses and give the function the information it needs. It needs the variable called player choice. So give it that variable called player choice. Now, here's another really, really valuable piece of data. It's smarter to copy and then paste the names of your variables so you don't make a typo. Now, let's run this. And look. We actually get you chose to attack the troll because we called the function called troll. Well, now that we have that working, we have a little bit of fun. We can call it over and over again. Let's call troll and pass in the number 2. Actually, yeah, let's do it right. Yeah. So now we get both. We get the first function call where player choice, the variable, was equal to 1. And so we got this, you chose to attack the troll. He defeats you. Then we called it again and passed in the character 2. So, of course, it did this branch. What will happen if we call troll and pass in the word frog? Anybody guess? Nothing. Nothing happens because we didn't provide an option. Now, there's a lot more logic you can put inside here on how to handle every possible input that could come in. You'll learn about that on the boot camps. But you see, we can call troll over and over and over again. Again, every single time one of our players encounters a troll and puts in a choice, all we have to do is capture that choice and make this call right here. All right. So to recap, we've covered an entrance point. In most languages, it's the first instruction in encounters. Sometimes that changes a little bit. I'll show you that later. We covered variables. We made a variable called player and gave it information, a value. We even changed the value later. We covered control and branching statements. Here is a control and branching statement. Here's another one. And finally, we covered subprograms. We made a subprogram, and we successfully called that subprogram repeated times. Now, I know this is a super simple example. All of this code is on one half of a page, but every element of the 5 basics, the fundamentals of any program, is illustrated here. We're about to look at the full code, and you'll see each one of those 5 elements is present in this longer, more complex program. So I would like you, Regina, to post the link to the full code in the chat. You'll see a link that looks like, you'll see a page that looks like this. Here's all the code. Do a Control A, Control C, or however you need to select all the code and copy all of it. Then go back here, delete everything, and then paste in the new code. And then run it. I'm going to give everybody, I'm looking at the time here, I'm going to give everybody about a minute to just play the game a little bit, see what happens. I'm going to follow the path right because that sounds like fun. Ooh, wise choice, adventurer. Magical lake blocks my path. Whirlpool. I'm going to use a spell. Oh, good. Oh, wild bear. I think I'm going to feed the bear. Oh, good. Okay. Hidden grove with a mystical tree bearing golden fruit. I'm going to cut down the tree. I'm feeling like an idiot. Oops, you died. Okay, good. Dang it. All right. Okay, good. So there's the game. Everybody stop playing. And we're just going to take a moment here and look at some of the basic elements of any computer program and where they are in this code. One of the first things to look at whenever you get any kind of computer program that you're going to be working on is to look for the entrance point to get as close as possible to the beginning. We talked about that earlier. Well, if we go to the top here, we have this thing called a class. We didn't get into what classes are. You learn all about that in the boot camp. But this is a type of object that will exist inside your program. We have a thing inside the program called a game, an adventure game. And in it, look, we have a function called init. Look, this is a long function. Look at everything that's inside this function. It goes all the way down to right here. All of that is initialization. From here down to here. That's all initializing. And if you read through it, you can see how that could be because we got some kind of a variable. Why do we know it's a variable? Well, look, we have this equal. And we learned earlier that with the equal symbol, on the left is a variable. On the right is the data to assign to the variable. So it looks like this is some huge amount of data that gets assigned to the variable called steps. I like the way this is written. It's pretty intuitive that this is a collection of steps that people will go through. And they certainly are, aren't they? Look at that. We got the steps. Oh, okay. Good. So we have a bunch of steps. And that is all these steps are contained in one variable. It's called steps. Good. All right, we can kind of read through this and make some sense of it. If we were given the job of changing one of the steps, we could probably find the step pretty easily. All right, now let's go down. We're done with this function. We have another function here because it says define. This is to shuffle the options. Notice each time you played it, the options were different. Like I had options. 1 was cliff, 2 was go to the right, and 3 was investigate. Next time I was playing, they were in different order. Okay, good. So here's another function. Play a step. And this function displays a description, and it gets the player's choice. Notice also in here, we have if statements. And that's all there is to this game. We've got another function, end the game. If score is greater than or equal to 15. Wow. Restored balance to the kingdom. Lower than 5. Wizard looks eerily similar to Eric Gross. Jack wrote that for me. Thanks a lot. Because my co-founder. Okay, good. I'm so sorry if you encounter a character that looks eerily similar to me in a game. I think that's that whole Five Nights at Freddy's horror genre. All right, so now last thing I want to show you is we talk, because I've shown you some control and branching statements. There's variables. Clearly, there's subprograms. There are all these functions. What about the entrance point? One of the more unique things about Python is that a lot of the time when you create a Python program, you specify the entrance point explicitly. And it happens right down here. If you start studying programming using Python, you'll see this convention over and over and over again. All this is saying is, if you're in a file in your computer program and the file has this code, that file is the first file that'll be used. Remember, computer programs can have many different files of code. Hundreds, sometimes thousands, often thousands of lines of pages of code. Each one's a separate file. If your Python program has this line in it, you're looking at the first file that will be run as soon as they start the computer program. That's all. So another helpful thing when you're learning Python. Not all languages have a nice little feature like that. But there's always a way for a given language to figure out what the first line of code is. And it's so valuable to do so. All right. We just covered a lot here. There's some more things to do, but I'm going to switch over. Let me stop sharing. And by the way, you can tweak that program and mess around with it and have fun with it. And honestly, you can build up on it and make something pretty cool. All right, let me switch here. Okay, so we went quite a little bit, I don't want to say over, but I've got time for one question, and then I'll give you an opportunity to be able to send out your other questions in. Regina, do you have any cool questions?
There's a couple at the bottom there.
Yeah. The whole way that main thing works and why it's not up front at the top, this is a question. Like I think someone's HQ is asking the initialization, how come that's not up front? It's just a peculiarity with Python that you learn the details of on the bootcamp or any kind of study you do with Python. Notice when we were writing our code, we didn't even need that thing. We didn't need to specify where the entrance point is. When you're building more complex Python code, it can be helpful, and that's simply the way the designer of the language made it. If you'd have to ask Guido von Rossum why he designed it that way, that it's not up front, that's just the way he designed his computer program. His language. There's more nuance to it, but between you and me, and I've done a lot of Python coding, it's not honestly going to be that important. It's just, that's the way the language works. That's where he decided to put it. I hope that helps. Bianca was asking about a thing about like why I chose 3 if statements, because there is another part of the Python language called an else if. I did it just to make the concept dead simple. If I was writing this as production ready, like a real game, I would have used a little more complex languages. I want to illustrate those fundamental concepts in as simple a manner as possible. But you're absolutely right, Bianca. There are more advanced constructs inside the Python language that I could have used to build that, but it would just add a lot of complexity in what is meant to teach fundamentals. That's a good question. Yep. Okay, good. Anything else, by the way, you're going to have an email you can use here in a moment to send in questions and other things because we're giving you a free gift. So stick around here, please. I want to go over a couple of things about our boot camp. The next things I'm going to talk about are not for everyone in this class, but they might be appropriate for you. And I want you to find out if they are or not. Also, like I said, we've got a gift at the end of this. So let's talk about our boot camps. I'm going to be very upfront about this. You all have been really, really good to give us time to learn some of these fundamentals, spend time in our class. I'm just going to ask you to just listen to what I have to say about us. We do these because we enjoy it, but we also want to let people know who and what we are. We're not the right place for everyone, but when you hear details about what we are, you might find the right place for you. We've got 12 coding boot camps. This is more coding boot camps than anybody in the world offers. And these are not like some quick kind of spin them up real fast. Each of these boot camps was developed over a period of months or years. And they've been battle tested and have hundreds and hundreds of graduates from each one. They are precisely oriented to do two things. One, every single one of them lays in the fundamental foundation that you need as a technology worker to understand all the concepts involved just in working in tech. And the second one that each of them does is it drills in with a focus on a particular area, whether it's artificial intelligence, front-end development, Python, C#. It adds on to that fundamental basis we laid in and gives you a tight focus on an in-demand, like valuable area of the industry. There's a lot of areas you can move into in tech. We've tried to encompass all of them right here. So there are a lot of ways you can break into tech if you want to. You can go to college, you go to a boot camp, you can do self-study. And when it comes to boot camps, there's a lot of them. Here's what we believe is different about ours that may be valuable to you. The first one is, I said it before, they're self-paced. That means you don't move like as part of a cohort. You don't like say everybody starts on March 1st and we all move through the material at the exact same pace. We do not work that way because learners don't work that way. I don't work that way. When I'm learning something, there's parts of it that I do really well with and I move through pretty quickly and I'm grasping it. I'm able to apply it. And there's other things where I just slow down to a crawl where I'm like, there's something about this I'm not getting. I know I can inevitably eventually figure it out, but it doesn't go fast. I don't want to provide a learning experience where when people hit those, because they will, everyone does. But when people hit those stumbling blocks, so there's things that just take a little more, that they get left behind. Do not want to do that. So our programs are self-paced. You're given the time to get through those spots. They're also flexible. You set your own schedule. You do want to put in a consistent amount, enough time to get through it, but you set your own schedule and you can enroll 365 days a year. So they're approachable. And the content, man, that's probably the most important thing that we've worked on over the last decade. It's very well-rounded. It's in depth. In a period of a few months, you are going to actually learn both those fundamentals and current technologies that the industry needs so you can get into the industry as fast as possible. And they're also affordable. We pay a lot of attention to the industry. We know what the national average is. It's like $12,500 or something like that for the national average on boot camps. We're priced under that for a better product. Well, better for the right person. Understood. We're just giving you all the data. The other thing is, our programs don't just teach you the tech side of it. They also include job placement training. Because learning to code is a different thing than learning how to get hired in tech. Each of them has their own specific successful actions, approaches. But you need to know how to get hired in tech. It's different than lots of areas. I've worked in a lot of different industries. Getting those jobs in tech is different, and we teach you all about how to do that. And you get access to our job placement directors who are really experienced to help you get into tech. And most importantly, our programs are designed for absolute beginners. There's programs out there where you have to take some sort of a coding test to check whether or not you've got sufficient baseline knowledge. It's almost like you need to know how to code before they'll teach you how to code. We don't do that. Our programs are designed so that no technology knowledge or coding experience is required. As long as you can read, write, do basic math, you can get through the programs, and you don't have to be a nerd. It helps. I like being a nerd, but you don't have to be a nerd to go through all this. So who are our programs for? They're for anyone looking for a better career. We'll cover this in a minute in more detail, but tech is a great industry to work in. There's remote work opportunities, there's better work-life balance, and it pays really well. So we've been doing this a while, and we've gotten really good at it. These are some of the awards we've gotten throughout the years. Every year, consistently, we land on every major best coding bootcamp list, and we work really hard for that. These are not given out lightly. We know lots of schools that don't get these awards. And this is what our graduates and students have to say about us. We have an average 4.8 star review rating across all the major review sites, because there's actual boot camp review set websites out there where people leave their experience and they say good things about us, which is awesome. We work hard for that. So why would you consider working in tech? I want to be really clear. I meant what I said at the beginning of this. These classes are designed to give you a little bit of a taste to decide whether or not it's even right for you. So you experienced a little bit of what the coding is like, right? There's obviously a lot more to learn there, but let's just talk about the technology industry itself. Tech work has a really good work-life balance. In all my years in tech, it's so rare to ever see a company that consistently requires you to work more than 40 hours a week, as an example. That's not true of other industries. And tech workers are very valued, appreciated for the hard work and contribution, and get really great benefits. One of those is remote work. Now, this was a little less rare before COVID, a lot more common now. But here's the cool thing is, because the industry has oriented so well around remote working, technology work, which is uniquely suited to being remote, is now, it's just a real common thing. Every once in a while, in the media, you hear about companies that are like, everybody come back to the office. Us tech workers don't want that. And so if you want to work remote, there's a lot of opportunities. So the other thing that's really cool is it is a very creative industry. I know that the machines that we use, these computers, they're mechanical electrical machines. They operate according to exact preset principles. And sometimes you might think that, like, well, that means the people that work in that area are going to be very methodical, very logical, very much like machines themselves. There's a certain part of how you have to think when you work in this industry that does resemble the machines you use, but the art of creating software is a very collaborative, high communication, creative activity. Yes, the implementation, the actual writing of the code, it has to be technical. It has to conform to standards, but the creative part of it is very, very present. And because of that, people take a lot of personal pride in their work. You can create, like, here's the thing. We make software to help people. And when you've been responsible, you're on a team, and that team created a thing that gets in the hands of the end users and makes their job easier, makes the company more profitable and stick around, solves problems in the real world. It feels fantastic. So it can be a lot of personal pride in what you do. And the final part of it is, look, money isn't everything, man, but you do want to get paid well for what you do. Knowledge workers who solve difficult problems should get paid well. And tech is a great industry for that. There's knowledge workers in lots of different disciplines. But you look at the tech industry, it is a stable industry, consistently keeps growing over the decades. It pays really well, and there's regular increases in pay. It's not a industry that's been around for 200, 300, 400 years. It's very established. It's very commoditized. Lots of people can do it. It takes hard work to learn how to do it. It takes creativity and discipline and collaboration to solve the difficult problems. And you get paid well and recognized for it, which is really, really nice. So These are some of the reasons to work in tech. Now, let's talk about the barriers to entry if you're going to consider the boot camp route. Because there's 3 routes into tech: college, university, boot camps, and self-study. But let's just look at, like I said earlier, boot camps aren't for everyone. So let's look at the money part of it. Boot camp tuition can cost thousands of dollars. It can, right? You're dealing with in a period. Look at the thing you're going to get in a period of 3, 4, 5 months. If you apply yourself and are willing to work hard and you find the right program, in 3, 4, 5 months, you've changed to a new career that could make you $60,000 or $70,000 a year to begin with, and within a couple of years be breaking 6 figures, and then experienced people make $150,000, $200,000 a year or more without a college degree. That's pretty amazing. But you pay for it. It costs thousands of dollars, right? Well, here at our program, Tech Academy, we have multiple financing options. There's upfront discounts. There's monthly payment options. There's a lot of options there, right? But that is a barrier to entry. That's why it's not for everyone. The other one is time. There's a fair bit to learn, as I'm sure you can imagine, to actually become a well-rounded entry-level technology worker. In other words, one of our graduates. There's a fair bit of time to get into it. And so you have to put in that time. You have to make that investment. Some boot camps approach that with a cohort system where they're saying, listen, you got to put everything else off into your life, in your life on hold to a great degree. And you give us, say, the next 4 months, 5 days a week, Monday through Friday, from 9 in the morning to 5 p.m. And we're just going to bang this out and everybody's going to move through. That is massive impact on your time. We don't do that. But you do have to put in the time. Some boot camps are only in person. Like come into the campus, sit down, do the study, work with the people around you. It works for some people, not everyone. So we do both. We have our campus in Oregon, and you can do the programs fully online. The other thing that's really cool here is that you can choose your study schedule. So yes, it's a required time investment, but if you've already got a job and you're trying to do this, juggling everything else or being a parent or whatever it is, you've got to put in a certain amount of time, but you're in charge of when that time is. And that's the other part of it. You can do part-time. Yes, it's great if you can do full-time. It's actually really cool. But the program works for part-time, which means you can study concurrently to hold down your job or going to school in some other area, which is really, really, really helpful. Now, you do have to have some technical interest or ability. This is not the kind of thing where you're like, I can't stand tech. I really hate logic, but I'm coming into it just for the money. Not going to go really well. The fact is, that technical interest and ability is going to carry you through the program. Not all bootcamp programs are made the same. And this is why we're talking about this. Very often, the technology education materials that you'll find are actually too hard. Now, there's a lot of reasons why. We go into that in other presentations, other classes we give. But one of the biggest one is that very often technology educators assume too much prior knowledge on the part of the student, even when they're making introductory material. The fact is, and I've learned this the hard way, it's very difficult to remember what it was like before you knew something. And when the thing that you know is big, massive area like software engineering that can cover a lot of ground, and you're an expert in it, it's very difficult to picture what it was like back when you didn't know anything about it all, and to make curriculum materials that respect where someone's at, but lead them forward gently through the whole process of mastery. And you don't find a lot of material like that out there. We've worked really hard to make our material that way. Because of that, again, you don't have to be a nerd to get through our programs, and you don't have to have any technology background to enroll. You can get this through this program. If you're reasonably bright, can read and write, and do basic math, you'll be fine. It's just a matter of, yeah, you got to handle the money, and yeah, it takes some time to get through. So I said before, this isn't for everyone. I understand it, but I'm asking you right now, like, is it time for a change, right? Are you working in a dead-end job where there's an income ceiling for you and you can see it? Are you like not working at all or unemployed? Is it really important to you that work-life balance be good and you can work from home? You want more time with your loved ones. And biggest one, maybe you're doing well, but is it a time? It's just time for a career change. And something that you saw here sparked that in you, that there might be something in tech for you. Well, good. That's what we're here for. The Tech Academy is the bridge between just the average person, people in the world, and technology. We're trying to make that bridge as easy to cross as possible. You do have to cross it. You have to take the time and put in the investment. But when you walk across that, well, most of our graduates make on average $30 an hour in their first job. You do the math on that, that's $60,000 a year. Where can you learn a trade that in a matter of months, without necessarily even having a degree, gets you into a $60,000 a year job? I've looked around. I spent a lot of time looking. I haven't found many things like that. Because of that, because of this, because we've worked with people from all different walks of life, we have become career change experts. If you're already working in an area, you've been out in the marketplace a while as a working adult, and you want to make a career change to tech, we know that switch really well. In fact, most of the time, you don't even have to take like a pay cut from what you were doing before. You make more when you graduate, which is pretty awesome. We've got over a decade of experience in helping people break into tech, and we've had over 1,000 graduates that are now working in technology. And that's everywhere from like small businesses, because lots of businesses need technology, even if they're not a software company, but all the way to the big ones. We have people that have gotten, jobs at Nike and Facebook and Disney, Uber, Epic Games. It depends on what you want to work at and how hard you work to get that job. So as a reminder, we have open enrollment. You can start anytime. And I encourage you to apply now. That's what this is for. And again, super appreciate you guys, being here and listening to this. I know this last part of this isn't for everyone, but if it's for you, if you genuinely want to break into tech, we know how to do that better than anyone in the world, in our opinion. It's our sole focus and has been for over a decade. And we've worked so hard to make it so these programs are accessible to anyone. So go to this link. Regina dropped into the chat, right? And then here's a real important thing. When you go to this link, if you've already filled it out at some time in the past, because we have a lot of visitors here, who have already been to some of these classes, you've already filled it out. The next steps to go through will pop up as soon as you log in. Go through those steps. I just want you to find out whether or not this is the right thing for you. And those steps educate you on everything about the Tech Academy and all of our programs and the boot camps and how we teach, and see whether it fits what you need to help you. But go through those steps. And when you go through them, you'll find videos, articles, and there's a step in there if you want to even book a call with the admissions department. So I'm going to pause for a moment if anybody wants to click on this and fill it out. And we'll get to cover the free gift and a couple of other really cool opportunities for you. By the way, if you are taking the login screen, you can see data at the bottom of this slide on how to log into your account if you already have one. All right. Now, a couple other quick things. We do have a referral program. Since their graduates are really happy with us and tell their friends, referrals have always been one of the top enrollment sources for us. And we make that program available for anyone, whether or not they're one of our graduates, which means we pay a 5% commission payment for all enrollments. So if you refer someone to us and they sign up, we immediately cut you a check for 5% of that amount, which is really cool. So how can you take advantage of this if you've got friends that you really think we should be talking to? In a moment, I'm going to go over a free gift. You need to email some information in for us to send out to you. When you send that email in, if you include the name and contact info of your referrals, we'll register them to you. We keep very close track of this, and we'll get you a commission check. Now, a couple quick things in preparation for the gift. We have a lot of books that we've written, 7 publications actually, including 3 Learn Coding Basics in Hours books, a coding book for kids and young adults, a technology basics dictionary, a project management handbook, and a book called You Are Not Stupid. Now, I want to expand on You Are Not Stupid a little bit. The first course on all of our boot camps is very powerful and is our most popular course and has been for years. It's called the Computer Basics course. And that course is designed to eliminate all mystery and confusion from every area of technology and computers. So you are starting the rest of your boot camp from a very firm foundation. People love this course. What Jack and I did is we took all the material in that course and put it in this book, You Are Not Stupid, and even added in additional items, including like even a history of technology that shows how we even arrived at the point we are today in all the areas of technology that we all live with every day. You Are Not Stupid is an awesome book. So the free gift. For those of you who have been all the way through today's class, we want to give you your own copy, physical copy, of a softcover copy of our Intro to Python book. In it, you'll find a lot more explanatory data about the 5 fundamental elements of any computer program, a whole lot more about Python. You'll see all, like one of the students referred to like different ways we could have written the code. It'll cover all of that. This book will teach you a lot. So a couple things. One, it's for students in the US only. Unfortunately, we can't ship overseas. 2, to get your copy, grab the email that's on the screen there. Regina put it in chat, and give us your full name and your full mailing address. We're actually going to send you your own copy of this. So we need street address, city, state, and zip, right? And if you have questions that we didn't get to about the class tonight, write them into the email. They get passed on to me. If you've got referral names and contact info, drop that in the email. We'll keep track of it. So there's the email. I'll pause for just another minute for anybody who wants to grab that email and shoot us a request for the gift. Oh, fantastic, Kimberly. 3rd time attending this month. She's going to sign up for the data science course. That one's really good. And then mobile app course. That's fantastic. That's wonderful. Okay. All right. So I want to cover one last thing. We have a link tree. If you're not familiar, it's a way in one location to share all of your connections and links and everything. So if you go to that URL, you'll see the Tech Academy's link tree. We just dropped that into chat. Okay. What's on there? Well, our free educational YouTube video playlist is on there. This video will go up there in a day or so. Links to all of our books and the dictionary. Upcoming meetups. If you want to attend future classes or tell other people about future classes, the link is in there. And of course, links to all of our social media accounts. So what do we ask here? 1, please follow us on social media. It helps us and you'll be the first to know when we do new things. 2, invite your friends to these classes in the future and tag us on social media. It helps a lot. And finally, if you'll do that last thing, link to the next event and tag us, then we'll enter you to win your own copy of You Are Not Stupid. This was a big old hefty book at 300 or 400 pages. We don't just give this one out for free, but if you'll share the next event link and tag us on your social media account, any social media account, we'll see it because we get tagged, and we'll throw you into the running to win a You Are Not Stupid. We hand out one of these each week. I think you'll love this book. All right, so thank you for attending. Make sure that if you filled out this form that you go to when you hit this link, if you filled out the form, follow the steps following that contact form. Go through those steps. You'll learn so much about whether or not this technology industry is right for you, whether our programs are right for you. We just want you to find out. I thank you all for attending. It's fantastic that you were here. I love seeing repeat people come to these and all the contribution, right? Auntie says, yes, I appreciate that, Auntie. I hope the 49ers win too. I will be very happy. Jack, of course, is not as big a fan as me. He would probably say, yay, sports ball. Go team, go. Anyway, glad you all came. Come to our next free class. I think you'll love it. And we'll see you at the next one. You're welcome, Myra. Thank you.